Hello guys, now I'm looking at question 10 of pre-mathematics June exam. So the question 10 says a cubic function has the following essential properties. It has got these very important properties. So they are saying f into 0 is equals to 8, which means that when the value of x is 0, the value of y is 8. Remember, mathematically, we are used to say f into x. So where at the position of x, it's 0. So they are saying if we substitute x with 0 on a function f, we are getting 8. And this appear to be the y-intercept. Whenever x is 0, and the y coordinate, like in this case, it's 8. Whenever the x coordinate is 0, we know that we are talking about the y-intercept. So this is the y-intercept of a function f. The function f cuts the y-axis where y is 8. So 0 and 8 represent the coordinate of the y-intercept. Now they are saying f into 4, it's equals to f into 1, which is also equals to 0. So they are saying actually when x is 4, y is 0. Even when x is 1, y is 0. So these are what we call the x-intercept. So the x-intercept of a function, the x-coordinates of the intercept of a function f, it's 4 and 0 and 1 and 0, meaning that the graph cuts the x-axis at 4 and it also cuts the x-axis at 1. Now they are saying prime, f prime, which represent, now guys, if I give you something like this, if I say f prime x equals to 0, what am I talking about? F prime x is a gradient at any point. When you see f prime x, you know that this is a gradient. F prime x represents the gradient at any point. Now, if I say f prime into 3 equals to 0, so I'm saying the gradient is equals to 0 at a point where x is 3. F prime into, so this is my x value, it's 3. So I'm saying f prime of 3. So the gradient, it is 0 at a point where x is 3. So what are we talking about here? We know that the gradient is actually 0 at the turning point. So they are saying the x turning point is 3, another x turning point is 1. Okay, so let me try to sketch the graph answering the question of 10.1. When I sketch the graph, I will do this. I will say, I know this is the y-axis, this is the x-axis. I know the y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. The y-intercept is 8. So the graph touch the y-axis at 8. Okay. Another thing that I know is the x-intercept. I've got 1, 2, 3, 4. So the x-intercept, according to the information, it's 1 and 4. These are the x-intercept. And I know the x turning point is 3. The graph turns when the value of x is 3. And it also turns when the value of x is 1. So it means 1 is the x-intercept and it's also the turning point of a graph. So how does the graph looks in this case? it means the graph goes like this. Remember, at free, they are saying the graph will turn. And they're saying f into free is equals to 8. Oh, actually, wow. F into free is equals to 8. When x is free, y it's 8. I have another point here. I'm mapping x and free and 8. I have another point here. And remember that, okay, they also said whenever x is free, the graph turns. So the graph turns there. It go and turn again when x is 1, and it goes like this. Sorry for my ugly graph, but hopefully you get the idea. The intercept is 1 and 4, and they told us that when x is free, f into free equals to 8. When x is free, y is 8, which is this point, 3 and 8. And we also now know that free is actually the x turning point, because they said f prime of free is equals to 0. So if we say f prime of free equals to 0, we know that the gradient is 0 at free. It means that free is the x turning point. Okay, so this is our graph. Okay, let me try to put this graph here, because I will need the information of a graph. I see that I will need the information of graph. It touch at 1 and 4. It goes like this. It turns at 3 and 8. Turns at 1 and touch the intercept at 8. Okay, let me do this. Let me do this. Because the y-intercept is 8. Let me do this. It touched the y-intercept at 8. This is 1, and this is, actually this is 1 and 0. It's a point 1 and 0, and this is a point 4 and 0. This is a graph of f of x. Okay. Now they say show that the defining equation of f is. So they want us to find the equation of f, the equation of this graph. How can we find the equation of this graph? You are going to say f at x equals to a into x minus x1, x minus x2, x minus x3. Okay, so this is the formula that I normally prefer to use if I know the intercepts, the coordinates of the intercept. So what I'm going to do now, I'm going to say f of x equals to a into x minus, my x1 is going to be 1. This is my first intercept, it's 1. And I'm going to repeat that x-intercept. I'm going to say 1 again. So my x1 and my x2, I'm going to substitute them with 1. This happens whenever the x-intercept, it is also the turning point. So you can see that my graph f of f, it turns, the turning point, it's 1 and 0, and that 1, it is also the x-intercept. Now you are going to use the 1 twice. You are going to substitute it on x1 and you substitute it on x2. Why? Because this x-intercept, it is also acting at the turning point. Whenever you see the x-intercept, which is also the turning point, you are going to substitute it twice. On x1, you say 1. On x2, you say 1. So now you say x minus, what is my x free? It's my x-intercept, which is 4. So now I'm going to figure out this A by using any point on the graph. Which point do I have on the graph? I have a point 3 and 8. It's also a point on the graph, which is also the turning point. And also, I think I also have 0 and 8. So I've got this point of the intercept, of the y-intercept. So the coordinates of the y-intercept, it's 0 and 8. So let me use 0 and 8, the y-intercept. So I'm going to say f of x, it's 8. Substitute x with 0. Substitute x with 0. Substitute x with 0. Therefore, 8 equals to a into 0 minus 1, it's minus 1, minus 1, minus 4. Therefore, 8 equals to negative 1 times negative 1 times negative 4 is negative 4a. Divide both sides by negative 4. A is negative 2. So let me check if the A is, yes, here is the A. The coefficient of f of x, you can see here, the coefficient of x cubed, I mean, is negative 2, which is my A. So A is negative 2. So what you have to do now, you just say f of x equals to, remember you now know your A is negative 2. You say negative 2 into x minus 1, x minus 1, x minus 4. Okay, now you expand f of x equals to negative 2. Let me expand x minus 1 and x minus 1. So it's x squared minus 2x plus 1 into x minus 4. You keep expanding. F of x equals to negative 2. Now I'm going to take x squared, multiply it with everything on the other bracket. So I'm going to say x cubed minus 4x squared. Do the same with negative 2x. Multiply it with everything in the other brackets. Minus 2x times x minus 2x squared minus 2x times minus 4 plus 8x. Do the same with positive 1. Multiply it with everything in the other bracket. 1 times x is x. 1 times negative 4 is negative 4. F of x equals to negative 2. We can group like terms. X cubed minus 4x squared minus 2x squared is minus 6x squared. 8x plus x, it's 9x minus 4. So you have minus 2x cubed plus 12x squared. I'm multiplying throughout by negative 2 minus 18x plus 8. That is the equation of f of x. Okay, now the last question on question 10 is determine the value of x for which the graph of f is concave down. Okay, when you are answering this question of concavity, determine the value of x for which the graph of f is, you must first find what we call the point of inflection. You must first find the point of inflection when you are answering the question of concativity in a cubic function. You must first find the point of inflection. And the point of inflection can be found by taking the two x turning points, divide by 2. So what is your x1? It's 1. And what is another turning point? It's 3. So 1 plus 3 divided by 2 is 2. So the point of inflection, the x coordinate of the point of inflection, it's somewhere here, 2. So now we say this part of the graph from the left coming to this value of 2, the graph is concave up. I will say C up. And then from 2, this other part of a graph, it's C down. It's concave down. So this point of inflection, is the point where the concativity of the graph changes. So the graph was concave up all along. Now it starts to be concave down. So the question say, determine the values of x for which the graph of f is concave down. F is concave down whenever x is greater than 2. So if you look at these two, on the right side of the 2, the graph is concave down. But on the left side of 2, the graph is concave up. So when x is greater than 2, this f of x is concave down. So finding the point of inflection, it's very, very, very important. How did I find the point of inflection? I took the two x turning points, I divided by 2. Another way of finding the point of inflection is to derive your function f of x twice. You can say f prime x, this is your first derivative, minus 6x squared plus 14x minus 18. Then you derive again f prime prime x. You derive the second time minus 12x plus 14. So now you have got 0 equals to minus 12x plus 14. Yeah, this is 24. Sorry, guys. This is 24. It's not 14. If you derive 12x squared, you get 24. This happens when you are tired. I know I've been talking and talking. So let me say this again. Another way of finding the point of inflection is to derive twice. So you derive the first time, you get minus 6x squared plus 24x minus 18. Now when you derive the second time, you have got minus 12x plus 24. So 0 equals to minus 12x plus 24. You can take 12x to the left. 12x equals to 24. It changes the sign when it comes the sign. So you divide both sides by 12. X equals to 2. So the point of inflection, it is 2. So we say the function is concave down when x is greater than 2 in this case. Because on the right side of 2, it's where the function is concave down. Yes, I think I've exhausted myself. I wanted to continue with the problem of question 11 and 12, but I'm tired. I've been talking and talking. Maybe I should just do question 11. But let me not exhaust myself. I will continue question 11 and 12 tomorrow early in the morning. So thanks, guys. Please subscribe.